Okay, so we talked about the universal law of gravitation. Now we're going to talk about Earth in space. So there's going to be a lot less physics in here. It's going to be just more um, conceptual stuff like ideas. So it's a little bit of a break from the math. And then we'll get back into it a little bit in one more unit, and then we'll be done with the math. So our objectives are going to be to demonstrate how Earth moves in space and to explain the causes of the cycles of the seasons on Earth. So that's going to be a really important one on the quiz, like what causes the seasons. And this, what causes it is the tilt of the Earth of it on its rotation around the sun. Okay, so we'll talk about that again. How Earth moves. So this is going to be on the quiz as well. Astronomy is the study of celestial bodies of space, not astrology. Astrology is a fake science. Astronomy is the study of celestial bodies of space. So rotation is going to be the spinning of an object on its axis, and an axis is just an invisible line through that object as it's spinning. So, imagine you have a basketball spinning on your finger. If your finger would have an invisible line that went straight through that basketball and out the top of it, that would be its axis. So that's what causes day and night, and it's 24 hours on Earth. Our day and night cycle is 24 hours on Earth. And that's going to be what we're going to use as units later on in more math. So the revolution is the movement of one object around another. So the Earth around the sun or the moon around the Earth, it's just something going around another object. And so the one Earth revolution equals 365.25 days, and that accounts as one Earth year. And remember that 0.25 days is why we have the leap year. So every 4 years we have an extra day, and that's in February. And then an orbit is just the Earth's path, the orbit of many celestial bodies in our solar system is elliptical. So the Earth's path around the sun is not circular, it's elliptical. It's kind of like an egg. And so here, this is just a picture of our seasons. So, we've got our tilt on our axis. It's 23.5 degree tilt. You can see that little invisible line through there. That's the axis. So with our tilt, as we get to the December winter solstice, we're going to see that the southern hemisphere is getting more light and more direct light than the northern hemisphere. I mean, look how far, this is where we are, right up here, okay? And so then we've got Alaska over here, which sometimes it receives 24 hours of sunlight, sometimes it receives 24 hours of daylight. So in the December solstice, which is the northern hemisphere's winter, the Earth is tilted away from the sun for the northern hemisphere. It's tilted towards the sun for the southern hemisphere. And so this is the equinox where it's not tilted really away or towards for any hemisphere. This is going to be when you have 12 hours of daylight, 12 hours of sunlight, or of nighttime. And then the June solstice, which is our summer solstice, is when the northern hemisphere is tilted towards the sun and the southern hemisphere is tilted away from the sun. So we're going to get more heat and more daylight in the summer solstice. And then in the winter solstice, we get less heat, less direct sun rays, and less daylight. So the more heat is because of the direct rays hitting the Earth. Okay, and then here's just a nice little picture of Earth's elliptical orbit. It's not perfectly circular. So here in January, we're 91 million miles away, and then here in July, we're 94 million miles away. So we get a little farther away from one time than another on our orbit. So this point is a little farther than this point, and so that creates a little bit of an egg shape. It's not quite a circle. So the seasons of Earth, we have 4 seasons: winter, spring, summer, and fall, or autumn, wherever, some people call it autumn, some people call it fall. Autumn comes from Latin autumnus, and that is just like a more seasonal, like scientific term. Fall, I saw a funny meme, leaf fall, so it's fall. Sunlight either hits the Earth at a direct angle or an indirect angle, or just like a more direct angle than other places. So that means it's warmer near the equator, which is basically a direct angle right at the equator, and that's why the equator is so warm. And then it's going to be colder near the poles, because you get kind of an indirect angle towards the poles. And so here you go. Light hits at an indirect angle. It spreads out more on the ground, and then it also reflects more. So you're going to get cooler areas. And then right here at the equator, it hits pretty directly, just straight on. There's no spreading out. It just hits this small little area, and that's why this area between here is hotter than this area up here and this area down here. So light's just hitting that angle and spreading. This is going to be the summer of the southern hemisphere. So this is going to be the northern hemisphere's winter. So the northern hemisphere is tilted away from the sun, and the southern hemisphere is tilted towards the sun. So it's just going to be hotter down there. So more about the seasons on the Earth. The seasons are because of the tilt of the Earth. I've told you this about 6 times now, so we need to remember that. It's a 23.5 degree tilt, and it is not caused by the distance from the sun. Seasons are not caused by the distance from the sun. They're caused by the tilt of the Earth, and that's due to these rays. Right here. We've gone over it a bunch of times, so if you have any questions about it, let me know, because I can go over it again. So the summer or the solstice are days when the sun is farthest north or south of the equator. So the northern hemisphere's summer is going to be June 21st. That's the northern hemisphere's summer solstice. It's its longest day. And then the northern hemisphere's winter solstice is December 21st, or its longest night. And that's going to be inverse to the southern hemisphere. So if you remember what inverse means, it's opposite. So the opposite here, the southern hemisphere is going to experience winter on June 21st and its longest night, and then it's going to experience summer, December 21st, and its longest day. So an equinox is when the noon sun is directly overhead, and equinox just means equal night, and so that means that we're going to have a 12-hour day and 12-hour night. And then we've got our vernal equinox, and that's March 21st, and our autumnal equinox, September 21st. So just remember what equinox means. It's 12-hour day, 12-hour night. And right here you can see September equinox, March equinox. We've got a 12-hour day here. Once it spins, it's going to be a 12-hour night. We've got a 12-hour night here. Once it spins, we'll get a 12-hour day. And then there's just, again, the tilt of the planet on its axis revolving around the sun, causing the seasons. So that's all we've got. It's a short and simple one. If you got any questions, comments, or concerns, let me know. Otherwise, have a wonderful week.